Hey guys, yesterday we talked about one-step equations. Today we're going to talk about solving two-step equations. And two-step equations simply means that we are going to use two steps to solve for x. Remember, we're still getting x by itself in order to solve it, but this time we're going to do two steps. Now let's recall that we have to work backwards, okay? That is important. We're working backwards and we do PEMDAS backwards. So instead of thinking multiplication and division first, we're going to undo addition and subtraction first, okay? Then we'll handle the multiplication and division. So let's look at the examples. If I look at example 9, 6x plus 8 equals 50. I'm going to handle the addition first. The addition first. Okay, so that means that I am going to do the opposite, the inverse operation of adding 8. I'm going to subtract 8 on both sides of the equation. Now remember that balance restaurant on vocabulary. We got to balance the equation. On the left side, the 8's cancel, so I just have 6x. And then on the right side, I'm left with 42. Now I'm going to get rid of the multiplication. So you see how I worked backwards. I did addition and subtraction first, then I did the multiplication and division. So to get rid of multiplication by that 6, right, I'm going to divide by 6. Remember, inverse operations. I divide by 6 on both sides. On the left side, the 6's cancel. I've now gotten x by itself. On the right side, I got 42 divided by 6. Well, 42 divided by 6 is 7. Okay, so I know x equals 7. Once you get x by itself, you're good to go. Let's look at number 10. Again, 2n minus 5 equals 11. I'm looking at the minus 5 first. I'm going to get rid of the subtraction first. So that means I do the inverse operation. I'm going to add 5 to both sides. When I add 5 to both sides, on the left side, the 5's cancel. So I'm doing the great undoing. I'm getting n by itself. So I got 2n now on the left, and it equals 16. Now I see 2 is being multiplied by n. So now I do the inverse of multiplication, which is division. So I'm going to divide by 6. Or I'm not 6, I'm sorry. I don't know why Miss Bennett said that. Not 6. I'm dividing by 2. Instead, I'm multiplying by 2, so the inverse would be to divide by 2 on both sides. To the left side, the 2's cancel. To the right side, I end up with 16 divided by 2. So on the left, I got n equals, well, 16 divided by 2 is simply 8. Okay, let's look at 11. Again, we're going to do inverse operations. We're not getting confused that there's a negative in front of that 4. That still is just saying negative 4 divided by k, or multiplied by k. So I got to go to the addition and subtraction first. I got to subtract this 9 first, okay? The sign here just means that the 4 is negative. That does not mean subtraction. So I'm going to go subtract my 9 first on both sides of the equation because I got to get k by itself. Okay, so to the right side now, this time the 9's cancel and I end up on the left with negative 4k. K is almost by itself, but not quite. It equals 4. Now again, I want to get k by itself. I notice negative 4 is being multiplied by k. So I need to do the opposite of multiplication. I need to do division. I am going to divide both sides by negative 4. 4 divided by negative 4 is negative 1. And then on the right side, again, negative 4 divided by negative 4 cancels. That's just a 1. So I end up with k equaling negative 1. Okay, my last one, guys. Again, I'm getting y by itself. I got to take care of this first. Now look at that 7. It is positive. So I need to do the opposite of a positive 7. I need to subtract 7 on both sides. It's tricky how the way they order it, but what I'm doing is I have a positive 7 here, and I got a negative 3y. So I'm really subtracting 7 from both sides. So the 7's cancel to the left. On the right side, I'm left with 27. I'm going to move my 3y down, and I'm not going to forget the negative sign. So this is negative 3y. Are you seeing that, guys? And that negative 3y, I see it's being multiplied by that y, so I got to do the inverse operation. I have to divide by negative 3 on both sides. Okay? Once I divide by negative 3 on both sides, I end up with a y equaling negative 9. Next, we have some fractions, but we're not going to get scared. We're just going to undo the addition and multiplication, and then we'll just do the opposite of the fractions, okay? So let's look at 13. I look and I see that I'm subtracting 7, so I'm going to undo that first. So I'm going to add 7 to both sides of the equation first, doing the inverse operation. When I add 7 to 9, I end up with the 7's canceling on the left. On the right side, I end up with 16. So I have a x over 2, or divided by 2, it equals 16. And now I just think of the inverse operation. If 2 is being divided by x, that means I just need to multiply both sides by 2. Okay? So I need to multiply both sides by 2. Now to the left side, those 2's are going to cancel, and x is going to be by itself. On the right side, 16 times 2 is 32. X equals 32. Let's go to 14. 14, the same thing. I'm just going to undo the addition and subtraction first and then handle the division here. So I see 8 is being added, so I am going to subtract 8 on both sides of the equation. Okay? Once I subtract 8, the 8's on the right side of the equation cancels, and then I have 11 minus 8. 11 minus 8 is 3. So I end up with 3 equaling c over negative 5. And now I'm going to do the inverse operation to get c by itself. If I am dividing by negative 5, then Ms. Bennett's going to multiply both sides by negative 5. Now on the right side, the negative 5's are going to cancel out. So I'm just left with c by itself. On the left side, I'll have negative 5 times 3. Well, that's negative 15. All right, guys, let's go on to 15. And now we have a whole fraction being multiplied by x. We're not going to be scared. Remember, when we see fractions, we just multiply by reciprocal, okay? So I have this is 2 steps. So I got 2 steps instead now. First, I got to get rid of the 22. That's being added. So that means that I'm going to subtract 22 from both sides, right? I'm subtracting 22 from both sides. On the left side, 22's cancel. On the right side, I end up with a 6, okay? And that equals 3 over 5x. Here's the deal. To get rid of that 3 over 5, remember I'm going to multiply this thing by the reciprocal. Okay, so that means I'm going to multiply both sides by the flip of 3 over 5, which is 5 over 3. All right, so I'm multiplying both sides by 5 over 3. And look what happens on the left side. Everything's going to end up canceling out. That's just how it works. It all cancels out. It just goes away. And so I end up with just x by itself. And on the right side, again, the 6 is over a 1. So 6 times 5 is going to be 30. And then 3 times 1 is 3. 30 divided by 3 is 10. X equals 10. Let's go to the next one. I'm going to, again, undo this 1 here, this adding 1. I'm going to use an inverse operation. I'm going to subtract 1 from both sides, okay? So on the left side, the 1's go away, and I'm left with negative 1 over 3m. On the right side, I end up with a negative 8, okay? Then I don't get scared. I know when I see a fraction, I just multiply by its reciprocal, okay? And I'm going to multiply by the flip of this. I'm going to multiply by 3 over negative 1 on both sides, okay? So 3 over a negative 1. Now the left side, all of this stuff goes away. It cancels. So we're just left with m. On the right side, remember this negative 8 is over a 1. So if I got negative 8 times 3, well, that's negative 24. And then 1 times the negative 1 is just negative 1. Okay, negative 24 divided by a negative 1 is positive 24. Remember, negatives divided by a negative is a positive. All right, let's look at this last set, okay? We can do it. Remember, we're going to pay attention to the sign in front of the number, okay? That actually tells us what's being added or subtracted, not this over here. So really, in order to get rid of this 10 here, we're not worried about 7 over 4 because it's being multiplied. In order to get rid of this 10 here and get p by itself, I need to do the opposite. So I need to add 10 on both sides of the equation on this number, 17. Okay, so I'm adding 10, and then 10 goes away to the left. To the right, I got a negative 38 plus 10. Well, that's negative 28. Okay, so I'm bringing that down. Okay, on the left side, I'm going to bring down my 7 over 4. Remember, it's positive. So just my 7 over 4p. And I'm not scared. Now this looks just like our one-step equation. I know I need to multiply by the reciprocal of this fraction or the flip of it. So I'm going to multiply this by 4 over 7 on both sides, okay? 4 over 7 on both sides. All right? On the left side, it just works out where everything cancels when we multiply by the reciprocal. So I'm just left with p. And then on the right side, Miss Bennett's going to use her calculator, right? I got 28 over 1. So that means I got to take negative 28 times 4. Well, negative 28 times 4 is negative 112. And then I got to take 1 times 7. Well, 1 times 7 is 7. So I got negative 112 divided by 7. That gives me a negative 16. So P equals negative 16. All right, let's look at the last one. The last one, I got a 15 equals 9 minus 1/2. Again, I'm not afraid of this 9. I'm going to erase this over here so I can have space. Okay, so if I think about it, the 9 is positive. So my inverse operation would be subtracting 9 on both sides. I'm going to go ahead and subtract 9 from both sides. Okay, when I subtract 9 from both sides, I end up with the left of 15 minus 9. 15 minus 9 is 6. On the right side, the 9's cancel. Okay, so they go away. And then I'm left with, again, I keep the sign with its term. So I'm left with a negative 1/2 x. But I'm not afraid of this negative 1/2 x, okay? I know I just need to multiply by the reciprocal of negative 1/2 or the flip of that. So I'm going to be multiplying, and I'll do a little small x, but I'm going to be multiplying by 2 over negative 1, okay, to get this x here by itself. So I think to myself, oh, and I got to do it to the other side. What I do to one side, I do to the other side, 2 over negative 1. When I do that on the right, everything cancels. Bye-bye. Only thing we're left with on the right is our x. X is now by itself. On the left side, guys, remember this 6 is over a 1. So I'm saying 2 times 6, which is 12, over a negative 1 times 1. Well, that's negative 1. Okay? So, guys, if I look at that, x is equal to negative 12. All right, let's move right along.